history. When we hear that word, our minds typically travel back a few hundred, maybe a few thousand years. We think of the pyramids, standing silent sentinel under the Egyptian sun, stone monuments that defy time, carrying the whispers of pharaohs. We think of the Roman Colosseum, where the echoes of crowds and mortal combat seem to hang in the air still. We think of the Great Wall of China, a stone dragon winding over mountains, a testament to human will and persistence. To us, that is the definition of ancient. The entire recorded history of human civilization is a tapestry woven from roughly 5,000 years of delicate thread. But if we take a step back, that tapestry begins to shrink. Let's widen our perspective beyond the borders of human memory, into the realm of planetary history. This is a story told not in writing, but in pressure and time, etched into the very rock beneath our feet. Layers of sediment tell of oceans that came and went, of mountains that rose and were weathered into dust. Fossils trapped in amber tell of colossal forests and the strange creatures that once roamed the earth. This is the story of ice ages, of drifting continents, of life rising from the humblest beginnings, facing down great extinctions, and somehow enduring. This story spans not thousands, but billions of years. 4.5 billion years of Earth's history, a grand chronicle written in the language of stone, water, and evolution. Yet, even that story is but a single chapter in a much larger book. Let's pull back once more, out of the warm embrace of Earth's atmosphere, into the cold silence of space. Here, an even older story is being told. It's the story of our family, the solar system, a story that began 4.6 billion years ago in a vast cloud of gas and dust, the remnants of a long-dead star. From that chaos, gravity began its work, pulling matter together. At the center, a ball of gas began to heat, to compress, until it ignited with thermonuclear fire and became our Sunday. Further out, tiny dust grains collided, stuck together, forming rocks, then planetesimals, and finally, the planets we know today. This is our history, the history of every atom in your body, forged in the furnaces of stars and assembled by the brutal, beautiful dance of gravity. Throughout all this time, we have looked up at the night sky with a fundamental belief that everything out there, from our sister planets to the comets that streak past, was part of this story. They were siblings, born from the same primordial cloud, bound by the same sun's gravity. Our solar system was an oasis, a family surrounded by a seemingly impassable void between the stars. But that belief, our safety in our isolation, has been shattered. In recent years, we have come to realize that the void is not empty. Occasionally, visitors from other star systems, true travelers from the interstellar dark, pay us a visit. First came Oumuamua, a strange, cigar-shaped anomaly, tumbling in a way that defied easy explanation, forcing us to question the very definition of a natural object. Then came 2I divided by Borisov, a comfortingly familiar comet, a reassurance that other star systems were perhaps not so different from our own, that the rules of chemistry and physics still applied elsewhere. And then, the third visitor arrived. Its name is 3I divided by Atlas. It did not come as a mysterious rock or a familiar snowball. It arrived as a paradox, a presence that challenges the very timeline we just recounted. An object operating by rules we had never known, ejecting a colossal plume of water vapor in the freezing depths of space. But the most astonishing thing about 3I divided by Atlas is not its activity, but its age. Initial analyses, based on its chemical composition and its trajectory, all point to one unimaginable conclusion. A conclusion that this object may be up to 10 billion years old. Let that number sink in. 10 billion years. It's not an abstract figure, it's a span of time. A span more than twice the age of the Earth. More than twice the age of the Sunday. When this object formed, our Milky Way galaxy was a teenager, a much more chaotic and primitive place. The stars had different chemistries. The laws of planet formation may have been different. When 3I divided by Atlas began its lonely journey, there was no Earth, no Mars, no Jupiter. Our entire solar system was still just a cold cloud of gas, waiting billions of years to even begin its story. This object isn't just old, it's a relic, a survivor from a different cosmic era. This is not just a comet, this is a cosmic fossil, a perfectly preserved time capsule, carrying secrets not just from another star system, but from another age. It is a direct, physical connection to our galaxy's most distant past. A past we could only ever speculate about through computer models and the faint light of distant galaxies. But now, a piece of that past has arrived on our doorstep. This is not just the story of an astronomical object. This is an archaeological investigation on a cosmic scale, a mission to decode a silent messenger that has witnessed 10 billion years of galactic history. And that story begins with the most basic yet most profound questions. How can we be sure of such a bold claim? What clues, etched into its very ice and dust, point to such an impossibly ancient origin? What are the fingerprints of time that scientists are looking for to confirm its age? And if this theory is true, what then? What secrets are locked inside this cosmic fossil? What can it tell us about the birth of our galaxy, about the first generations of stars, about the elements long since lost to time? Could it hold the missing pieces to the story of our own origins? This is the journey into the mystery of 3I divided by Atlas. A journey to understand how a wandering ice ball can become the key to unlocking the first chapters in the chronicle of the Milky Way. A story of persistence, of solitude, and of the universe's incredible ability to preserve its own past. The investigation begins now. A claim that an object is 10 billion years old cannot be based on feeling or speculation. In science, extraordinary claims require extraordinary evidence. And to find that evidence, astronomers around the world are turning their most powerful telescopes into time machines, not for travel but for observation. They are performing a remote autopsy, analyzing every photon of light that carries information from 3I divided by Atlas. They aren't looking for a birth certificate. Instead, they are searching for the subtle fingerprints of time, clues etched into its very chemical and physical nature. This investigation rests on three main pillars, three different lines of evidence that all point toward the same conclusion. 3I divided by Atlas is an ancient relic. The first and perhaps most powerful pillar is its chemical recipe. Imagine our Milky Way galaxy as a developing civilization, and the heavy elements as its technology. Just after the Big Bang, the universe was incredibly simple. It was almost exclusively hydrogen and helium, the lightest, most basic elements. This was the universe's Stone Age. The first stars formed from this pristine mixture. They were hot, massive giants that lived short, violent lives, and when they died in fiery supernova explosions, they forged heavier elements, carbon, oxygen, iron, and seeded them into space. Astronomers call all elements heavier than hydrogen and helium metals. Each subsequent generation of stars was then born from a cloud of gas that was more metal, rich than the one before. It's a slow enrichment process playing out over billions of years. Our Sun, a relatively young star, was born in a well-developed metal-rich city of the cosmos. That's why our solar system had enough raw materials to create rocky planets like Earth and carbon-based life forms like us. Now, consider 3I divided by Atlas. When scientists point their telescopes at it and analyze the light reflecting from its coma, a technique called spectroscopy, they can read its chemical barcode. Each element absorbs and emits light at specific wavelengths, creating dark or bright lines in the spectrum. What they are finding is astonishing. The spectrum of 3I divided by Atlas shows that it is extremely metal poor. It's like finding a flint tool in an electronics store. This lack of heavy elements is a clear sign that it was not born in a rich environment like our solar system. Instead, it must have formed in a very ancient, very primitive environment from a cloud of gas that had not yet been enriched by many generations of dead stars. This chemical composition isn't just a detail, it's a fingerprint of a lost era. It screams that 3I divided by Atlas comes from the impoverished countryside of the early universe, powerful evidence for its immense age. The second pillar of the investigation is even more sophisticated. It turns 3I divided by Atlas into a giant nuclear clock. Many elements in nature have different versions called isotopes. Carbon-12, for example, is stable, but carbon-14 is not. Carbon-14 decays over time, at a very precise and predictable rate. This is the principle behind the radiocarbon dating that archaeologists use to determine the age of organic relics. But carbon-14 has a half-life of only about 5,730 years, far too short for cosmic timescales. The universe, however, has its own isotopic clocks. using radioactive isotopes with half-lives of billions of years, like uranium-238, thorium-232, or potassium-40. When our solar system formed, it contained a certain amount of these radioactive isotopes. Over the past 4.6 billion years, a significant fraction of them have decayed into stable daughter elements. The ratio of parent to daughter isotopes we see today on Earth and in meteorites is a clock that has been ticking for 4.6 billion years. Now, imagine an object that formed 10 billion years ago. It would have started with its own mix of isotopes, characteristic of that era. Over 10 billion years, its isotopic clocks would have been ticking for much longer than ours. The long-lived isotopes would have decayed more, while extremely long-lived ones might still be present. Scientists are hoping that future missions, or even remote analysis with incredibly sensitive instruments, can detect the isotopic ratios on 3I divided by Atlas. If they find a ratio that indicates 10 billion years of decay, it would be like finding a long-stopped watch with its hands still pointing precisely to the moment it was made. It would be irrefutable proof, written in the very nuclei of its atoms, that we are dealing with a true relic from the distant past. Finally, the third pillar of evidence lies not in its composition, but in its journey. Our Milky Way galaxy is not a uniform structure. It has a bright, flat galactic disk, where young stars like our Sun reside, and brilliant spiral arms are actively forming new stars. But surrounding this disk is a vast, spherical and faint suburb called the galactic halo. This is the home of the galaxy's oldest residents, ancient globular clusters, and the first generation of stars. This is the Milky Way's graveyard and its museum, where the most ancient objects still survive. The orbit of 3I divided by Atlas, when traced backward by astronomers, does not match the trajectory of an object recently ejected from a nearby star system in the galactic disk. Instead, it appears to have a highly inclined and eccentric orbit, suggesting it has been on a long, slow journey, possibly originating from the distant galactic halo itself. It isn't moving like a neighbor who just stepped across the street. It's moving like a traveler who has walked thousands of miles from an ancient and distant land. Its trajectory is its travel map, and that map points to a 10 billion-year-old past. When you put these three clues together, the primitive chemical recipe, the potential isotopic clock, and the lonely orbit, a remarkable portrait begins to emerge. A portrait not of an ordinary comet, but of a survivor, a silent witness born in a younger, simpler universe. A fossil, preserved in the cold vacuum of interstellar space, carrying the secrets from the dawn of time. Now that we have established its identity, the next question is even more captivating. What lies inside this time capsule? If this theory holds true, then the discovery of 3I divided by Atlas is more than just an astronomical finding. It is the equivalent of archaeologists discovering a lost library, containing not just the history of a single civilization, but the history of the world itself. 3I divided by Atlas is not just a rock, it is a treasure chest. A time capsule sealed in the cold vacuum, carrying secrets that could answer the deepest questions humanity has ever asked. Studying it is no longer observation, it's an excavation. So, what do we hope to find inside this ancient treasure? What secrets are waiting to be unlocked? The first and most fundamental secret is the chance to hold a direct, physical sample of the primordial Milky Way. Until now, our understanding of the early universe has been like trying to read a book from a mile away with a pair of binoculars. We look at galaxies billions of light years away, and because it takes time for light to travel, we are seeing them as they were in the past. It's a phenomenal technique, but it's like looking at an old, blurry photograph, distorted by distance and cosmic dust. We can make out the broad strokes, but the fine details are lost. 3I, divided by Atlas, changes the game completely. It's as if the universe tore a page from that ancient history book and mailed it to our front door. For the first time, we will have the chance to analyze an actual piece of that era. Our cosmological models of the Big Bang, of the formation of the first elements, the most foundational theories of science, will no longer be just theories. They can be tested directly. For example, the Big Bang theory predicts a very specific ratio of hydrogen, helium, and trace amounts of lithium in the early universe. By precisely measuring the ratio of these elements on 3I, divided by Atlas, we could confirm or challenge the most basic predictions about the birth of our cosmos. Furthermore, it could hold the answer to one of the greatest mysteries of the stars, the first generation of stars, also known as population 3 stars. We have never seen one. They are thought to have been giants made almost entirely of hydrogen and helium, incredibly hot, incredibly bright, and with very short lifespans. They were the first forges of the universe. 3I divided by Atlas, at 10 billion years old, could contain tiny dust grains that condensed from the stellar winds or supernova explosions of these very same mythical stars. Finding even one such grain would be like finding a bone fragment from the first common ancestor of all life. It would give us a direct glimpse into the nature of the first suns that lit up the universe. If discovering the galaxy's original recipe is like finding a lost history book, the second secret is even stranger. It's like finding chapters that describe creatures we never knew existed. 3I divided by Atlas may contain extinct chemical species. Our universe today is filled with a stable collection of 92 natural elements. But in the past, things were more complex. Many radioactive isotopes existed in the early universe but had relatively short half-lives, and they have almost completely decayed into other elements over billions of years. They are chemical fossils. We can only see their ghosts through their decay products in meteorites. But 3I divided by Atlas, an object that has been in a deep freeze for 10 billion years, may have preserved some of these isotopes at much higher concentrations than anything we have ever seen. Discovering them would give us a unique insight into the environment of the early Milky Way. The presence of certain isotopes, like aluminum-26 for example, is a sign of nearby supernova explosions. By analyzing the isotopic ecosystem on 3I divided by Atlas, we could learn how often stars were dying, how chaotic its birth environment was. It wouldn't just tell us what existed, but what life was like in the early Milky Way. Beyond isotopes, it could also contain minerals that don't exist in our solar system. Minerals form under specific conditions of pressure and temperature. A metal-poor and possibly much colder environment than our own solar nebula could have created crystal structures we have never seen. We could discover new forms of matter, extinct mineral species, providing a unique glimpse into the laws of physics and chemistry in a very different universe. And this leads us to the third, most profound and potentially world-changing secret. It deals with the greatest question humanity has ever asked. Are we alone? The story of life's origin on Earth is usually told as a local tale. Around 4 billion years ago, on a young, rocky and watery planet, a lightning strike or a hydrothermal vent provided the energy to turn simple chemicals into complex organic molecules. This primordial soup eventually gave rise to life. Comets from our own solar system may have contributed by delivering water and organic building blocks, but the story has always started here, on Earth. 3I divided by Atlas has the potential to completely upend that story. If, and this is a monumental if scientists find complex organic molecules locked within its 10 billion-year-old ice molecules like amino acids or nucleotides, what would that mean? It wouldn't mean we found alien life. It would mean something far more profound. It would mean that the primordial soup for life was not a special feature of Earth. It may be a standard feature of the universe itself, and it existed 10 billion years ago. It means the building blocks of life were readily available in the Milky Way 5 billion years before the Earth even formed. Contemplate that. 5 billion years, a span of time longer than the entire history of our planet. It forces us to reevaluate our place in the cosmos. Are we the first conscious beings, or are we simply latecomers to a universe that has always been brimming with the potential for life? Is it possible that life has sprouted on countless other worlds, that civilizations have risen and fallen before our planet was even a molten ball of rock? The discovery of organic molecules on 3I divided by Atlas would be a second Copernican revolution. Copernicus showed us we are not the physical center of the universe. This cosmic fossil could show us we are not its biological or temporal center either. We might just be the late arrivals to a cosmic party that started billions of years ago. From the chemical recipe of the first stars, to the elements long since lost, and finally to the possibility of a much more ancient origin for life. 3I divided by Atlas is not just a messenger, it's an encyclopedia. A physical connection to our most distant past, a past we never thought we could touch. So where do we stand after this journey into the secrets of a cosmic fossil? We began with a physical paradox, an impossible water engine operating in the freezing cold. We followed the scientists on their investigation, through the three pillars of evidence, from the primitive chemical recipe, the potential isotopic clock, to the lonely orbit, all pointing to one incredible truth: a 10 billion-year-old age. And we unlocked that time capsule, revealing the astonishing secrets within. From the primordial formula of the Milky Way, to extinct chemical species, to the staggering possibility that the building blocks of life existed 5 billion years before Earth. After all the data has been analyzed, all the theories considered, what remains is not just a collection of scientific facts. What remains is a fundamental shift in how we see ourselves and the universe. 3i divided by Atlas, in its silent journey, has become a cosmic mirror. And when we look into that mirror, we don't just see an ancient ice ball, we see the reflection of our own deepest past, and perhaps our future. This mirror shows us humility. Throughout history, we have acted as if we were the pinnacle of creation, the only conscious beings in a silent universe born at a special time. 3i divided by Atlas shatters that illusion. It shows us that the universe was a dynamic, complex, and potent place long before we arrived. We are not the first actors on the cosmic stage. We may just be the latest, having just walked into a play that has already been running for several acts. Life, if its building blocks existed 10 billion years ago, could have sprouted, evolved, and perhaps even faded on countless other worlds, in millennia we cannot comprehend. This mirror forces us to confront the possibility that we are not special. And in that lack of specialness, there is a profound connection to the rest of the cosmos. This mirror also shows us the miracle of existence. Contemplate the journey of this object itself. It was born near one of the first stars in the galaxy, ejected, and began a lonely voyage that has lasted for 10 billion years. It has drifted through the chaos of the early Milky Way, dodged supernova explosions, passed through molecular clouds, and survived for a span of time that could erode even the most stubborn of memories. And then, after all that, by a chance of almost impossible odds, its trajectory intersected with that of a small blue planet at the exact moment when the beings on that planet had just developed the technology to notice its presence. This meeting is not just an astronomical event. It's a rendezvous appointed by probability, a 10 billion-year-old date between the past and the present. Our existence here, now, to be able to witness and understand it, is an immeasurable privilege. Most importantly, 3i divided by Atlas has forever changed the nature of space exploration. Throughout the 20th century, our motto was onward and upward. We launched rockets to the stars, landed on the moon, sent robots to Mars. Exploration meant going to new places. But 3i divided by Atlas has opened up a new frontier entirely. Not of space, but of time. It has given birth to a new field of science, interstellar archaeology. We now realize we don't have to go anywhere. The universe, in its generosity, is sending the past to us. And 3i divided by Atlas is only the first messenger. Next-generation observatories, like the Vera C, Rubin Observatory, with its ability to scan the entire night sky every few days, are expected to find not one but dozens of interstellar objects every year. We are on the cusp of a reign of time capsules. Some may be young, some may be old, some metal-rich, some metal-poor, some may be barren rocks, while others may hold secrets even greater than those of 3i divided by Atlas. Each one will be a new page from the cosmic library, each telling a different story of a different star system, a different era. We are entering a golden age of discovery, where we will begin to piece together the true, diverse, and rich history of our Milky Way, one interstellar fragment at a time. Ultimately, the story of 3i divided by Atlas is a story about listening. For millennia, we have shouted our questions into the cosmos, hoping for a reply. We have sent out radio signals, golden records, invitations into the silence. But perhaps we have been going about it the wrong way. Perhaps our task is not to speak, but to listen to the stories told not by radio waves, but by the chemistry of ancient rocks, to listen to the epics written not in language, but in the orbits of lonely travelers. 3i divided by Atlas is more than just a visitor. It is a physical connection to our most distant past, a silent messenger carrying the story of 10 billion years. And perhaps the most profound secret it reveals is not in its chemistry but in its mere existence, that the universe has always been telling grand stories long before we were here to listen.